So this is a really beautiful algorithm. It's not quite as beautiful as the lattice algorithm, but it's pretty damn cute. Before I fill this in right here, I'm just going to write it off to the side the way I usually do on paper. And so I want to figure out what is 57 times 18. And I'm told to make this my halves column and this my doubles column. All right, so when you do a half, if you get a remainder, you just ditch it, right? So if I take half of 57, 2 goes into 5 twice with 1 left over. 2 goes into 17 8 times with 1 left over, but I ignore that 1 left over. So when you do halves, any remainders, you just chuck them. So 57, half of 28, that's 14. Always do the halves first. I'll show you why. Half of 14 is 7. Now half of 7, 2 goes into 7 3 times with 1 left over. We just ignore that 1. 2 goes into 3 once with 1 left over. We just ignore the remainder. So when we do our halves, we do our division, and we just chuck the remainder. We don't even worry about it. Now, you can only get down to 1 when you're halving because we're working with whole numbers. So that's why I do halves first. It tells me where to stop. Now, on the other side here, every time I have a halve, I need a double of the other number. So double 18, that's going to give me, let's see, 16, carry the 1, 36. Doubling 36, if I double 6, that gives me 12, carry the 1, 6, 7. Double 72, I get a 4, 14, 144. Double 144, I get 8, 8, 2, 288. If I double 288, let's see, doubling 8 gives me 16, carry the 1. 16 plus 1 is 17, carry the 1. 4 plus 1 is 5, 576. All right, now, anytime there is an odd halve, I need that double. So the next thing I do is I look for odd halves. Now, 57 is odd, so I'm going to put a little star here. I want that double. 28's even, I don't care. 14's even, I don't care. 7 is odd, I want that double. 3 is odd, I want that double. 1 is odd, I want that double. So now what I do is I just add those doubles. So usually on paper, what I do is I circle these. Circle. So I don't accidentally add one I don't want. So just adding those numbers right there, the starred numbers, the doubled numbers, I get 8, and 4 is 12, and 8 is 20, and 6 is 26. So 6, carry the 2. 2, 3, 4, 5, 6, 7 plus 8 is 15, plus 7 is 22. Carry the 2. 2 is in the hundreds column, so 2, 3, 4, 5, and 5 is 10. The product here should be 1,026, right? We'll double check that in a couple of different ways. So again, filling in this grid right here, I get halves, 28, right? Who cares about the remainder? 14, that's pretty easy. Half of 14 is 7. Half of 7 is 3, ditch the remainder. Half of 3 is 1, ditch the remainder. So don't even worry about the remainders. For every half, I need a double. So doubling 18, I got 36, 72, 144, 288, and 576. Now over here, I need to star the doubles to add, and I only star a double if it had an odd half. So 57 is odd, star. I want 18. 28, nope. 14, that's even. 7 is odd, star. 3 is odd, star. 1 is odd, star. Okay. So, and then for every one of these star doubles, I want to add them up. And that's what I did over here. I added up the 18, the 144, the 288, and the 576. That came up to 1,026. And my claim is that is 57 times 18. Now, let's do it a couple of different ways just to confirm. I'm going to switch the halves and the doubles. What if I halved 18 and doubled 57? halves versus doubles. Half of 18 is 9. Half of 9 is 4, remainder 1. We only care about the 4. Half of 4 is 2. Half of 2 is 1. That 1 tells me when to stop. So we always do the halves first so we know when to stop. And then over here, I need a double from 57. So if I double 57, I get 114. Double 114, I get 228. Double 228, let's see, I get 16, 5, 456. Double 456, we get 2, 11, 9, 912. And then anytime I have an odd double, so or odd half, I need the double. So 18, that's even. 9 is odd, so I need that double. 4 is even, 2 is even, 1 is odd. I only need those two doubles. So I need to add 114 to 912. 4 plus 2 is 6. 1 plus 1 is 2. 9 plus 1 is 10. I get the same product. Double check on your calculator. That's the answer. That's wicked cool, isn't it?